So here's a correlation question now, and I've kind of zoomed ahead a bit. I've already uploaded my data into a spreadsheet on my TI-Nspire and labeled it X and Y, made sure I had all the details. As we read over here, the bone density material, a person's bone mineral density, is a T-score, which is the number of standard deviations a person is above or below the young, healthy adult mean. And here's a bunch of university-age students measured here to see if there's any link between the mass of a student and their bone mineral density. So it goes straight into calculate Pearson's product moment correlation coefficient. So Pearson's PMCC, this is the regular correlation coefficient that we would normally run if the data is continuous variables, and if there seems to be some kind of positive relationship, and if there are no outliers. So what I'm going to do actually here, just to broaden the question, I'm just going to go doc, insert a data and statistics, and here we're going to have the X variable. This is the mass of university student, and here's Y. Here's the bone density. And can you see there seems to be maybe moderate linear correlation here, although it is quite spread out, right? So there doesn't seem to be any outliers here. This might be an outlier, not too sure, but it does tell us to calculate Pearson's to start with, all right? So we're just going to go back to this guy here, and we are going to click on space. We're going to go menu, we're going to go statistics, we're going to do stat calculation, and we are going to actually do a linear regression mx plus b, because if you look at question B, it does say find the least squares regression line. Now the least squares regression line is just the linear regression line. And we're going to put the X list is X and the Y list is Y. And off we go. So scroll down here. So the R value is 0.6. Oh, let's just go down here. There's the R value, 0.605. So we're literally going to just write that down. R equals 0.605. And what I've done here, I've given you a nice little reference chart, which will be easy to remember. You see it just goes up by 0.25s. And this is acceptable referencing in terms of, is it strong, is it weak, is it moderate? Okay, so this is very weak, 0 to 0.25, weak, moderate, and strong. So if you see the 0.6, it's moderate. So two words to describe. We're going to describe the strength, which is moderate, and we describe the direction, which is positive. So moderate, positive correlation. That's all we need there. And now B, find the least squares regression line. Well, we can write that down straight away. Look, it's Y equals mx plus b. And from the calculator, it tells us the m is 0.0319. So 0.0319 x. It tells us the b value is negative 2.44. I've done those to three significant figures. Okay, so this is the link between the Y value, which is the bone mineral density. So I suppose how strong the bones are, and compared to the weight. So weight or mass in kilograms gets fed into the linear model, and out comes a bone mineral density. Use your least squares regression to estimate BMD. Now remember, BMD is Y, great, when we have M, a mass of 92. So we are just going to use this when X equals 92, Y equals 0.0319 times 92 minus 2.44. We're going to go to the calculator. We're going to go to doc, insert a calculation page. I'm just going to type this in as it is. 0.0319 times by 92. That's minus 2.44. And we have the bone mineral densities 0.495. It doesn't say what units that's in, it just looks like it's just a number. And that will be to three significant figures. And then we're going to look at how reasonable is that estimate. So we're going to check two things. First of all, 92 for kilograms. Are we allowed to use 92? If we go back to, forward to our graph, Well, look, 90 is here, 95 is here, so 92 is definitely within, the data that we're using. Okay, so we are actually interpolating. So we're okay there, aren't we? If we're interpolating, we're not trying to predict someone with a mass of maybe 120 kg. That would be extrapolating, and there's a danger that we're not too sure what the model will do beyond this. If I just do menu, analyze, regression here, let's do that linear regression. Okay, we can see the actual line, equation of the line on there. And 92 is somewhere here, so this feels that we can use this line to estimate outputs for inputs. Then of course we might like to say that if we go back to the writing page here, it could be possibly unreliable as R is only moderate. Okay, so there's not a great strong positive correlation, so we would have to say that it's just an estimate, and it could be a wide estimate, so we're not too sure how accurate our prediction will be there. So now if we look at the data again from a scatter graph, we might see that this point here might be an outlier, so that might give a hint that maybe a different type of correlation could be used. Now if there's an outlier, or if there isn't a linear pattern, but there is a pattern but not linear, then we would use the rank, and that is Spearmans, and that's what the next part tells you to do. So we would have to compare the above numbers with the below numbers, and best you just do this straight on the page. So we've got a 1, we've got a 2, and we've got a 3, so we can cross those off. A 1, a 2, whoops, there we go. Oh, sorry, 1 is F, so it's going in smallest to biggest, my bad. Let me just delete that. So F is 1, B is 2, and I is 3. Okay, so we just want the next one up to be 4. After 66.7, it seems to be C is 4. And after 75.4, just keep scanning. Oh, I missed the one here. H seems to be the next one, okay? So you can see I'm doing it live here as well, so there's a chance to make mistakes. So just always just cross-check. So it looks like H is 4. Just take your time with it and cross it off. And then C seems to be the next one, 5. I keep scanning after 75. It seems to be this D is 6. And then A is 7. J is 8. E is 9. And G here is 10. Okay, so now let's look at the Y values. So 1 is F, let's cross that. So it's gone from small to big again. H is 2. And D is 3. Okay, so small to big, the next one. Well, there's only one more negative, and that's here C. So that's the next one at negative 0.3. C is 4. Now we want fifth one. So the fifth one, no more negatives. Fifth one is A. Now into 0 points. Next one here is B. That's 6. And now we've got, okay, so we've got joint 7th here. So if this is 7th and this is 8th, we just average the 7 and 8. 8 plus 7 is 15 divided by 2. That will be 7.5. So G and I are 7.5. So that's 7 and 8. We just need 9 and 10. 9 for J. And 10 for E. So you can see it just takes some time. We've got to be careful, precise. There's some joint ranks there. I'll make this big now. And then you'll see how long it takes. And even though I'm quite experienced at this, it still takes time. Now here's the important thing. I'm going to do doc now. I'm going to insert. I'm going to insert a new problem. Okay, so if I insert a new problem, option 1 here, and I choose a spreadsheet. Now the reason I'm doing that is so I can actually type in X now and Y again for the ranks. Now previously if I did that on the 2 points, the X and Y were already taken by your previous data. Okay, so now just type this in carefully in order for X's. 7, 2, 5, 6, 9, 1, 10, 4, 3, 8. You notice there's 10 items and I've got a 10 entry here. Now scroll back to the top. And now for the Y values, I've got a 5, and a 6, and a 4, and a 3, and a 10, and a 1, oops, 10, and a 1, and a 7.5, and a 2, and a 7.5, and a 9. Alright, now what I'm going to do is I am going to go doc, I'm going to insert, and I'm going to insert a data and statistics page again. And I just want to see what the new scatter graph looks like for the ranks. Okay, so this is Spearman's rank correlation we're doing here, X here, and Y here. Now does that look any clearer compared to the previous one? So there's 2.3, there's the actual values, the original data, and here's the new data. It doesn't look like there's much change. Okay, so when we do now performing the R value for Spearmans, we actually just go through the same process. If I go back to the ranks in here, we just go and ask the calculator to work out the correlation coefficient for the ranks. And this is called Spearman's rank correlation coefficient. So menu statistics, stat calculation, and we're going to do a we'll do a linear regression again, option number 3, and again we just choose the X values here because that's the only variable, and here's the Y value here. Off we go, and let's scroll down. Let's see what's happened to the R value. So the R value here is 0.620. So R here, oops, R here is 0.620. So previously, I'm going to put R of S, Spearmans, and R of P for Spearmans, 0.605. So look, even if we rank the data, both are hinting only moderate positive correlation. Okay, sometimes if you switch from Pearson's to Spearmans and do the ranks, and the ranks actually then zoom up in terms of the value in terms of correlation coefficient, then you can conclude actually there's strong positive correlation. But for both measures there's moderate positive correlation, and that's the question.